Coming up on this episode of the IoT Inc. Business Show.
My definition of AI is really what I would call the deep neural net learning. So it's using neural nets, and neural nets try to simulate the brain. If you think of the brain with neurons, you've got layers of neurons working to help you make a decision or make a movement. And so the mathematics of the technology here is try to emulate what goes on in our brain.
Although AI has been around for over 60 years, it's only been relatively recently that it's been practical to apply it to real-world problems, such as those found in IoT. 1, because the computational power is now available, and 2, because the vast amounts of data are now available to train it. In this episode of the IoT Show, I speak with Richard Boire about the differences between artificial intelligence and analytics in the context of IoT.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is made possible by sales of my book, IoT Inc., published by McGraw-Hill, and the IoT Inc. Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com. With me today on the IoT Show is Richard Boire. Richard is Senior Vice President of Innovation at Environics Analytics. He has over 30 years of experience in data science and has developed predictive analytics solutions in virtually all industry sectors. And his book, Data Mining for Managers, was published in 2014 by Palgrave Macmillan. Richard, welcome to the show.
Thank you, Bruce. Thank you very much.
So where did the name Environics come from?
Well, the name Environics came from, there's a parent company called Environics Research, okay, which is where the president is Michael Adams, who is a very, very well-known market researcher. He's currently, in the Order of Canada and has done a lot of groundbreaking work in terms of trying to look at attitudes and perspectives amongst Canadians. My boss, Jan Kessel, who's the founder and president of Environics Analytics, decided that it would be a good idea to try and look at the data mining, data science side of things, and the data that one actually captures. And so she saw that as a good fit with the market research folks who in a lot of ways only collect data on a limited data set, whereas people like myself, Jen, and others are collecting. We're collecting data on a large number of records. Sometimes it's not unusual for us to have data on more than 1 million records, 1 million customers. So we're actually collecting information again. And when I say information, where it's been given permission, because there's been a lot of, as you know, there's been a lot of news lately about Facebook and Cambridge Analytica, and my company is certainly very, very vigilant. And
is this a disclaimer, or are you already making a disclaimer here?
No, it's very. We've always adhered. We've always adhered to those privacy regulations about if the customer does not want to be marketed to, then we're not going to have access to that data.
All right. So, now, where are you getting this data from? Are you scraping it like Cambridge was doing, or different sources?
Well, I mean, the primary source and where my company generates most of their revenue is really from what I would call aggregate level data, which is data at a postal code level, or from your perspective or from the United States perspective, a zip code level. So we're not gathering data specifically about a particular customer. So we have built products, we built custom segments where we use this aggregate level data that we've been able to generate at a geographic area level, i.e. zip code. Now, we get a lot of that data from StatsCan. StatsCan is our big supplier here, where they will, they conduct a census every 5 years, where they ask Canadians a series of questions, pertaining to their demographics and other sorts of information, which is then publicly available, to all Canadians. So our expertise and experience is about using that data to create other products from that publicly, and I repeat, publicly available data. Now, that's where most of the lion's source of revenues come from. But our company has expanded into the area of customized analytics, data mining, data science, which is where I come from and which is where I've spent 30 years of my life in, which is I'm working with data that's collected, that's gathered from an individual customer.
Okay.
So
what type of data is that?
That type of data would, might be, if I'm a travel company, like let's say AAA, I would have a customer database where I would have information, related to my past behavior, whether how many subscriptions I have, how many roadside service how many roadside service calls I've made or that I've had, other products that I've bought from the AAA. Like AAA will also sell insurance because it's a natural fit with their their service offering. So I will have information related to their insurance behavior, related to their transaction behavior, and also related to their activity from a roadside perspective. That's all at the individual level. So we're gathering, AAA is gathering that information, but in order for AAA to use that information, they would be reaching out to their customers to make sure that that they want their information to be used for marketing purposes and to be marketed to. That discipline is we're seeing a lot with the press. Again, I'll repeat the Facebook Cambridge situation. Marketers, we've always had this situation of trying to be very respectful of consumers' data. And so most of the very, very good marketers have always had policies in place, regardless of what the government legislation has been, simply because it's the right thing to do for the customer. And it's also bad. You do not want the bad press. So the good marketers have always been upfront in trying to address and respect customer privacy. I would say it's maybe I'm slamming some of the tech companies, but some of the tech companies are new. They've not been around for a long time, and so there's this lack of understanding. I mean, now we're seeing Zuckerberg sort of coming with oh, I'm sorry, but let's face it, he's a gazillionaire, but he's a young guy. He's 33. He's not been around as long as a lot of the traditional marketers who've always had experience with with customers and being respectful of what they the customer really wants and what and how that customer wants to use their data.
How in touch are you with the regulatory, space in Canada? Is it catching up to reality? Is it just letting industry sort of do what it's doing?
Well, that's a good question, Bruce. I mean, I was involved about 13 years ago. Canada put in the PIPEDA legislation, which is the Personal Information Protection Electronic Documents Act. I remembered it. And I was part of a roadshow that the Canadian Marketing Association put on. And I traveled with the president of the Canadian Marketing Association. There were a couple of lawyers. And what we were trying to do, because the Canadian government was coming up with this legislation, I believe it was in 2003, 2004 when they enacted it. And we were just trying to give businesses, throughout the country, because we went and presented, what the legislation would mean, to marketers. And we went to a number of cities. We went to, Calgary, Edmonton, as well as we did, we did one here in Toronto. But again, we were trying to, we had the lawyers trying to explain the legalese. I was brought in because I was a practitioner. Like I'm working with data every day. So they thought it would be good to have a practitioner. I had to be very careful about what I said, but they brought me in because they knew that I've, my position is I always want to analyze data where customers, where we have permission. Because the thing is, I can tell you, if a customer doesn't want you to have access to their data, I know that they're not going to be a highly responsive or a customer that I want to target. So, because just by their very nature, I'm not, my models are based on my models are not going to show them to be a sort of a highly predictive person in whatever target variable I'm trying to optimize. So. Again, I mean, the legislation is really about consent. It's about reasonability. Like if you're using the data and the customer's giving you consent, because marketers and data scientists can use the data in a variety of ways. You have to ask yourself, is the way that I'm using the data reasonable enough for the customer to understand how I'm using it? So a good example is, you're a not-for-profit, so you're like Red Cross, and Red Cross decides to give you insurance. And they use data science to do that. That's not a reasonable expectation on the customer, because they're not expecting you to use their data to market them a product which is completely different from their core offering. So those are the kinds of things that marketers and business people always have to ask themselves is how if I have a core offering and I'm offering another product and I'm using data to do that, isn't it really ancillary to what I'm doing, or is it completely different? And so that's where you have to look at the customer standpoint. Would this be reasonable for the customer to give informed consent? And then the last issue, so there's the three: consent. Would the customer really understand how you're going to use the data? And then the last one is governance. Like, is my data secure and protected? So those are the three. There were 10 basic principles. Underneath the 10 underlying principles are those three sort of overriding goals. And so that third one is about governance and security. So those are the things that this legislation is trying to do. And I think now with social media being ever so prevalent, we're seeing that this whole issue of privacy, because I come from sort of like most of my experience, because I've been in the business for 30 years, is in more the traditional areas, but we're seeing with social media that the privacy issues is really on steroids. Because it's what we can do with that data, and we have access to it in a very, very in an almost immediate way. Customers are being targeted with ads, depending on what website they go to. These are all these ads that we're seeing on our screens are all driven through data science, and by looking at the customer's past behavior. And there's a whole business around the notion of programmatic advertising, where companies are bidding, to put something in front of you, on a particular website.
Yeah, yeah. Well, no, that's an interesting topic, and we've delved into data privacy a number of times in the podcast. But let's pop up and give us give us an idea of your experience in both AI, which is kind of the topic, and IoT.
Well, my experience in AI, and we'll get into the definition a little later, is, as I read the different definitions, and I have a specific definition of AI, but
what's your definition?
My definition of AI is really what I would call the deep neural net learning. So it's using neural nets, and it's using it in what we call a deep neural nets, which is looking at, without getting too technical, neural nets try to simulate the brain. And if you think of the brain with neurons, you've got layers of neurons working to help you make a decision or make a movement. And so the mathematics of the technology here is try to emulate what goes on in our brain. So typically what's happened with AI is that, in the past, we never had the technology or the capacity to really take, nor the data. So we didn't have the data, because there's lots of data, nor the technology to really take advantage of AI. So a lot of the solutions were very weak. I remember reading articles back in the mid 90s where they were doing image recognition, and the image recognition was very, they were getting maybe 50, 60% actually even lower than that, maybe 45 to 50% accuracy back then. But the breakthrough that happened, is basically with the breakthrough in big data, the ability to process data in parallel. So the notions of, we've all heard of Hadoop and MapReduce. That ability to process data, lots of data in a very, very quick way, all of a sudden gave us the ability to employ these kinds of technologies. And the second thing is, because we now had access to more, now because we have access to more data and the ability to process it, we could start to really take advantage of the AI technology by looking at what's called, multiple hidden layers. So traditionally, they may have only had one single hidden layer, because in neural nets, you basically have three levels. You have an input layer, hidden layer, and an output layer. Well, basically, what's happened is now we've gone from single to multiple hidden layers, and in some cases, you're looking at hundreds of hidden layers where the accuracy can really improve. And so you're seeing breakthroughs in areas like image recognition and text recognition. I mentioned in image recognition it was around 45 to 50% back in the 90s. It's now over 90%. So that's where, today yesterday I got another, I get The Economist every month, and again, there's, on the cover is AI, right? Everything is about AI, but it is a very exciting topic because of that groundbreaking results that they've been receiving, where they went from 50% to well over 90% in being able to classify images. So that's catapulted this whole discipline into a number of different business applications. And so that's what I call artificial intelligence. But a lot of in the literature, or in a lot of the articles you read, they're encompassing AI as a lot of the other even more traditional machine learning techniques. So logistic regression, decision trees, multiple regression. They look at that as forms of artificial intelligence, because their definition is quite broad in the sense that they're looking at the computer, like the computer is actually doing something that the human cannot. So to give you a good example, I've been using, regression techniques, decision trees, and I've been using neural nets as well. But, I've been using, the traditional techniques for certainly 30 years. And when I'm working with the mathematics, I'm not going in and doing any calculation. The computer is not only doing the calculation, but where the learning comes in is actually like with a lot of these techniques, there is this feedback loop where you're getting iterations. So you input, let's say 20 or 30 variables, and the machine will actually go through a number of iterations, maybe 15 or 20 different iterations where it's going back and forth, trying to determine what variables to include and what variables to exclude. So the machine is doing that, not the human. And the machine is learning in terms of optimizing the number of variables, but it's optimizing it against the variable you're trying to predict. And it's also where it's not as strong as neural net, it's optimizing that against an expected distribution. So for instance, if it's multiple regression, it's linear. If it's logistic, it's sigmoid. Decision tree starts to get more advanced because it's non-parametric. Excuse me. And neural nets, where neural nets is it takes it to the next level. It is not assuming any kind of distribution. It will look at both nonlinear and linear distributions as in terms of trying to optimize the data.
All right. Well, let me just stop you there. So first of all, I kind of like your definition of AI, although it has an implication that you weren't really doing AI 10 years ago. Most of what seems to be classified as AI today, and this is where I think it's a little bit confusing, is, like you said, decision trees, regression analysis, cluster analysis. These are all analytical techniques, and right. So you can call them analytics. However, and then you could extend that definition a little bit further. So using your definition of neural networks and then effectively these different layers simulating, I suppose, the brain working in layers, you're having these hidden layers, but really in each of these layers, we're just talking about statistics, aren't we? I mean, we're still talking about analytics. It's just that it kind of relates to what you were saying earlier, where you're automating the process of optimization, although that's not happening, I don't think, in the neural networks. Well, I guess it is, but it's hidden, but it's still everything inside there. And correct me where I'm wrong, because this is a question as much as a statement. But everything inside a neural net is going to be still these traditional analytics techniques. Or am I off there?
It's you're kind of right in the sense it's using statistics. So, for instance, a lot of the techniques, a lot of the mathematical techniques, that are being used is using what's called gradient descent, which again, it's not a new mathematical technique, but basically what it's trying to do is, if a distribution is nonlinear, you've got, let's say, you might have multiple distributions or curves like within your data. And so you have sort of one kind of curve within the data or local distribution where the math is going in and trying to optimize that point. So if you're looking at you may have a bunch of data in one, and you have to remember you're looking at multiple dimensions, but you may have a sort of a localized area of data like in your distribution where you have a curve, and the math is trying to go in and optimize that sort of what we call local distribution. And it's doing that. If you think of a parabola, it's, the data is kind of going down. Let's think of a U-shaped parabola. The data is going down the U-shaped parabola, and it's going down, down, down. And if you think about your basic trigonometry of y divided by x, right? I think that's tan. That's the tan function. So it's taking y divided by x and it's finding, okay, y divided by x, there's a plus value. When it gets to the valley of that curve, the y divided by x becomes 0. So you could say it's found an optimal point. Right. And then it moves on. I mean, that's a very simplistic way of describing it, but from what I've read, that would be one that would be. No,
but just to understand what you're saying, I mean, effectively what you're talking about is taking the slope, and then you're saying when the slope goes to, let's say, a 0, then you found a valley or you found a peak, and that's an optimization.
Exactly.
Right? But again, here, just to try to dissect it a little bit, the techniques here are not new, but what is new, what seems to be new with AI, and you brought it up very well, saying that we've got the computational, the parallelization, is that we can then feed the output of one calculation into the input of another to optimize it, to speed it up, basically, I guess you could say to learn, but we're just really we're doing the same stuff. We're just automating it and putting it inside of a loop or inside of a loop inside of a loop to find this stuff quicker or to find it more accurately, right? I mean, there's nothing new here that we couldn't find in a textbook a long time ago. It's just really the confluence of the computational power and what else? I guess that's it, right? I mean,
you're right. It's the computational power that we have, and we can now do it, and we can now take advantage.
Right. We can now do it, and we can do it in a way that makes sense. And then the neural networks take it to another level, even beyond that, because these layers will have internal loops, let's say, and then they'll have an output that goes to another layer. And from what I understand, sorry, go ahead.
I was going to say, I mean, you're right. We're, it's no, but the applications, the application of neural net versus what we've done, with other techniques in my world is no different. Mm-hmm. Is we're taking the output or solution, and in my case, I'm trying to rank customers in terms of whatever behavior I'm trying to optimize, whether it's response to an offer, are they likely to defect, or are they likely to go bad, are they likely to have a claim? So all those solutions which I've been building for a long time, that has not changed. The process that I take has not changed. I just now have access to more powerful tools in my toolkit, and AI or deep learning represents one of them. So I have, just to give you some more context, at Environics Analytics, we're always building models, and I have my guys who are doing a lot of things in the more traditional area. I say, when you build a model, send it to me, and along with the data, and then I'm always running, the deep learning or neural net techniques against that to see if I'm getting anything better.
So let me ask you this then. So the concept of a model is something that we've covered extensively, and really just at a high level, we're representing the raw data in a more manageable way. And tell me, is there a difference between, and I think I know the answer to this, but is there a difference between a cognitive model and an analytical model? And if you just think about what it is, and explain that a little bit.
Well, I'll try to. I mean, I've heard the word cognitive model, and I guess I guess my definition of a cognitive model is a model that, again, it's learning, right? It's the model continues to learn, which is
in learning, and to be pragmatic about it means we are doing a lot of iterations by taking again the output of one thing, putting into another thing, doing a tree, seeing if that makes sense, going back up. So it's just again, it's an intelligent way of going through the math to find things quickly, to find, I guess, more detail in the data. I don't know. Yeah.
No, you're absolutely right. It's about going through. It is about. I mean, consultants, I think, will come up with different words, and so the notion of cognitive, of modeling, in from my perspective, is, as you said, it's about using techniques, and is the model getting better? That's the thing here. Is the model getting better? The model will get better as it learns more based on the technique that you're using. So, with decision trees, it's going to be limited by the mathematics that's within decision tree versus, let's say, neural nets, which is going to be a lot more powerful. But again, the model, the model or the solution is learning in the way that that the learning is trying to achieve a better result.
So taking this into IoT now, one of the biggest differences, I think, with an IoT data set, and you can say an IoT based model or a model based on IoT data, is that data is living and it's continuously being updated.
Yep.
So we're continuously getting, often a time series based data, but we're continuously getting data. So when you're developing, and I'm just thinking here out loud, but when you're developing AI, and then we're going to get back to that in a second, but when you're developing AI for IoT, then you need to also since we have this iterative capability, we need to be able to pull in the inputs are coming from these sensors, and we don't just stop, right? We want to have this being a living model,
right?
That's continuously pulling the data 24 hours a day, 7 days a week, 365 days a year. So does that have implications, or is it? Again, so now just trying to shift this now to an IoT type situation where we're collecting a lot of internal data. How does that shape things, or is it really just the same stuff and we just need to pipe it as opposed to just read it off of, let's say, a database, or I don't know? What do you think?
No, I think with IoT, where the data, you have you have this whole issue of real time data and streaming data that's coming in. Mm-hmm. So this is where the application of AI makes just makes a lot more sense than the more traditional techniques. I mean, you can take the more traditional techniques and get them to get the parameters or variables to be adjusted, as we say, on the fly, with new data. Mm-hmm. But certainly my recommendation, or my given what I know about IoT and about the type of data and the volume of data, it just makes sense that you would explore something that is very, very, much more advanced. I would also look at it compared to other techniques, but, in theory, it would just make a lot more sense based on what I've seen, through my work, to look at AI first, see what kind of results you're getting, and then compare it to the other techniques, just to say, yeah, this is really achieving or delivering significant lift in performance relative to the other techniques. I don't think.
What are the other techniques then?
Well, the other techniques, as I said, like you have the decision tree, which is a popular.
Okay.
You have logistic regression, which is, for
analytical techniques.
So most data scientists, Gartner did a study. Most data scientists, I think it was just done in the last year, 67%, still use logistic regression, when they're building models and that's because the models. And this is in the non-IoT world. The models need to be explained to the business people. So neural nets.
That's a problem.
Exactly. It's very challenging to explain what you have. But in the IoT world, maybe less of an issue. Maybe I don't care, because I'm doing, the data is constructed in a different way where you're dealing with sensor type data. And so it's not the traditional way where I said it shouldn't be the traditional way, but in my world of customer analytics, where you're creating variables on each customer, you're creating all kinds of behavioral variables. And what I mean by creating, the data is not presented to the data scientist in that fashion. The data scientist has to manufacture or derive a lot of these inputs. But in the IoT world, that sort of variable creation becomes less of an issue with the sensor data, because you're working with the raw sensor data and then trying to see how that optimizes against a given solution. So a good comparison is like images. Like with images, you have pixels, and each pixel has edges and whatnot. Like there's not, the model or the deep learning solution is not going in and creating new variables. It's actually just taking the raw inputs, and it's using the layers to try and optimize those inputs, but it's not going in like a data science, like the way data scientists are traditionally done, where I take like raw transaction behavior and summarize it up to a customer level. That's done in a lot of the world of customer analytics, but in the area of image and text recognition, you don't have that same level of variable creation. It's a lot more automated. And so the same thing with IoT. Like I believe a lot of this data is automated, and you're looking at solution. You're looking at basically the tool to automate a lot of this variable creation. Whether the data is on batch or streaming. So I think you're going you're in the IoT world there's going to be there's to be extensive automation. But again, I think where I see the need or maybe the gap is evaluating how well these tools are doing. And I think that's maybe, and I'm hypothesizing, I think that may be a gap in the marketplace. So you built this great tool. What are you comparing it to? How do you know how good the tool actually is?
Yeah, to get the confidence level, you mean, or just
just to see, like if I had done nothing or if I used status quo, because these companies would have, if you're trying to predict a defect, right, a machine defect, companies would have had. I'm presuming companies would have had some intelligence to try and do that. So you want to compare that status quo to what you're now doing with AI, and that's as a data scientist, that's where in the 30 years I've been doing this, I've always been grounded on that. Like, okay, you're building a tool. Well, how good is it? Let's compare it to status quo.
And status quo, in this sense, are your traditional analytical techniques or your traditional statistical techniques that you've been using. Right?
Or even just traditional business rules. They may not even be using the traditional, as you say, traditional analytics. They may have just said, you know what, we know that this machine is going to defect, and here are the parameters based on our understanding of the business. So it's rule based, and they say,
right, which is a simple. I guess you could call that a simple formula as well.
It's simple. And most organizations are using that based on what they know about using their domain knowledge to come up with when a defect will occur. So you want to. I'm not trying to slam all companies. I'm sure companies are evaluating that, or some are. But I just think it should be a standard discipline within all organizations that they're measuring, the impact of these, of these new tools versus what they're already doing. And it's not a question of like what I often see is like, they're comparing, the predicted versus the observed, which is fine. I mean, that's not new, but I want to see. I'm more interested to see. Okay, well, yeah, but what other tool did you use? Let's compare it to that, to the accuracy of that.
Yeah. Okay, let me summarize what I think you're saying up to this point, because some of you have to cut through a lot of this hype. And so the first summary is at a very high level, AI, machine learning, deep learning. I'm probably missing a couple here. They're all analytics, and they're all statistics. But really the big difference here is they are a technique, and you've used that a couple times, so I like that. So it's a technique for automating analytics or statistics. It's a way of using what you've been doing for 30 years, but packaging it in a way that you can automate it, and that makes it kind of very suitable for IoT type data because of its nature, of the streaming nature of it. But really, at the high level, most of what most people are calling AI today can be called analytics. And then you're differentiating then one part. Okay, there is something new. There's a new technique under the hood. It's still using the same statistics, still using the same analytics that we've done in the past in a more discrete method. But under the hood, deep learning or let's say what was it that you were talking about? The deep learning or the neural nets. Neural nets. This I think we can call AI. Why? Because it's gone a little bit further. It automates these analytical techniques in a novel way. We may not know what's happening in those different layers, but you feel comfortable as a data scientist that's been working with analytics and statistics your entire career, but you feel comfortable saying, okay, that's AI. The other stuff, sure, we can call it AI, but really it's analytics and statistics. But we'll call this AI. And again, the AI isn't that it's something new, but what it is packaging the old in a way that automates it, that makes it better, and utilizes the computational power that we have today. Am I getting close to what you're saying?
Yeah, I would just the only thing I would preface is that you're right. The AI is just to be clear, the AI is not new. I mean, AI has been studied going back to the 1950s. There was research done at MIT. But as you say, the key thing you hit on is computational power. That's what we now can explore this, and we now can really, really take advantage of the principles of AI, which we could not do in the past because of computational power. And
going back to the 50s at MIT, what they're calling AI is really then a way of packaging, and correct me again, but it's a way of packaging the statistical techniques or the analytical techniques that they had at the time, which is still the ones we use today. But it's just again a technique. It's a way of organizing it, as a way of connecting it together. That going back to the 50s and what was originally called AI, again, was just a name for a way of organizing and connecting and iterating upon these traditional methods that have mostly been around for probably even 100 years. Or no?
Well, like regression. I think regression. I don't know whether it's been around 100 years. I know the regression.
A while anyway.
Regression was first used during World War II. When they were sending the
projectiles.
Yeah, projectiles, and Churchill. It was always. I'm a big fan of Winston Churchill. He had a real technical bent to him. Employed a whole bunch of scientists to try and come up with models to try and predict when the bombers, were going to be coming from Germany. So they were using regression techniques back in World War II. And after that, it was the credit card companies. The credit card companies started using regression type techniques to predict fraud and to predict credit risk. So, Visa, MasterCard, like Fair Isaacs. I'm sure, Fair Isaacs has been around since the 1950s. It was really, 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 really the pioneer of really one of the first pioneers of data science. They were using models back in the 50s to try and, predict the likelihood of somebody going bad. But I think like the work that was being done at MIT, you're right. They were exploring a number of techniques, but they were exploring, the concept of neural nets. I'm not sure of the exact details, but they were sort of fumbling around with neural nets back in that day, trying to see what they could find. So that when I'm talking about AI, and that I am referring to the notion of neural nets, because that has been studied since the from an academic perspective back in the 1950s.
Yeah, no, I like that because also, some people will define AI as trying to, I won't say simulate, but trying to, I'll say simulate the human brain, how a human thinks. And so a neural net, I guess, is one way that we can prehistorically look at our brain and say, okay, it's, although it's a net, not necessarily layers, but that's okay. And what's happened, I think, between now, or what's happened since the 50s to now, is these hidden layers that you're talking about. And so these computational layers where you've got the input, and probably at MIT in the 50s, they're probably just looking at one, maybe two hidden layers at most. But now we're talking, like you said, it could be up to 100.
And, a lot more.
or even more than that. Yeah. And just, I guess, in how you structure it. Okay. So that's helpful. I mean, again, we're just trying to cut through a little bit of this hype. And it just seems that the popular press is using the term AI, and maybe some aren't using it, and the companies aren't necessarily using AI because there's this maybe a bit of a stigma associated, because it has been around for half a century and obviously had some fits and starts that didn't really go anywhere because of probably mostly of computation. So now they're using the terminologies like machine learning, and but it's still just, cutting through everything. I think you can say it's all analytics, but there are certain techniques you can classify there that are neural net based, and these techniques again package and organize these discrete ways that we used to do things into a network. I guess that is a network that will then output. That'll give you a higher confidence and a better output than what we could have done before. But again, just because you can parallelize, like you're saying, and you can string and you can serialize the input and the output of these parallel computations to each other. And I mean, for people for you, I think this is old hat, and this is something that you just intuitively understand. But when you're reading in this subject, and everyone listening now is saying, okay, well, this is coming up all the time. It's just nice to know that really what we're talking about are these standard analytical techniques. However, wrapped, when we talk about AI, I like it, going into saying, okay, we can draw a circle around machine learning. I mean, we can around neural nets and let's say deep learning, and that we can call that AI, because it's really, again, it's not that it's a different type of mathematics. It's more of a technique. It's more of an application of the mathematics.
Yep. That's Bruce. That's certainly my perspective, that it's a technique, because most data scientists that are listening to this podcast will understand, or I think really appreciate what I'm about to talk to next. Like you've hit upon it, like it's really analytics, and analytics or data science to me is, we always, or when I'm talking to clients, it's a 4-step process. Okay. It's number one, which is identifying the business problem, or challenge. So there's that is phase one. Phase two is organizing the data. How do I create my analytical environment to optimize or to potentially optimize the solution? So that's stage two. Stage three is what tools or techniques. This is where we might employ artificial intelligence or
as a tool or technique.
Yeah, exactly. That's the third stage. The fourth stage is now I have a solution. How am I going to deploy it? Like, how am I going to action it? And more importantly, and I've talked about this with you just about 10 minutes ago, how am I going to measure it? How am I going to evaluate it compared to the status quo? So data scientists, when we're dealing with problems or projects, we're thinking about these projects or exercises, along these 4 stages. Like, what is the problem I'm trying to solve? How do I organize the data? Because we have big data. And the challenge today is, in the past, as I said, I've been around for a long time. In the past, I used to go to clients and say, give me everything you have, right? Give me all the data.
Yeah.
It was a lot of it, but I could deal with it. There's no way I would be asking for that now. The data scientist has to be more knowledgeable to say, okay, what kind of data do I actually need to work with to solve the business problem? And then there's a process, which I teach a course where I spend a couple of courses on this, which is trying to organize the data to create that analytical file. The third stage is the tools and techniques, as I said, which is AI. And then the fourth is implementation and measurement. So AI is a technique which is used in that third stage to help us come up with an analytic solution that's solving, the given business problem.
Yeah, no, that actually makes sense. And then the tools. So it seems to me that, again, just thinking about the data that's coming from IoT, as opposed to it being even legacy data, it's continuously coming in. So the technique of AI would probably make a lot of sense in that you can pipe that, you can automate it.
Yeah,
I think, right? And so you can automate the data that's coming in because, number one, well, I guess what the reason you're doing it is to continuously improve the model. So right. I suppose that's why you're doing it. And so I think people listening now, and, this is obviously a big subject, but AI maybe is coming up in IoT because it's a technique that can interface nicely with the data sources that IoT produces, that being, and we won't talk about external data, but we'll just talk about the internal data coming from sensors. But that seems like, again, a way that you could actually computationally organize that data coming in to go into an AI model. And it seems like because of the definition of what we're coming up here, or what it is of AI, that seems to lend itself very nicely to this type of data. Is that maybe why we're hearing about AI? Well, no, we've been hearing about AI outside of IoT, but it seems like there's a good relationship there.
There is, and if you think about those 4 stages, like the second stage, which is the
organizing the data,
working the data, and again, most of the data scientists that may be listening to this podcast will agree with me that most of the work that's done in a data science project is stage 2. It
could be 75%. You're going to say
more.
85%
plus spent on stage 2, which is organizing the data. Yeah. In the IoT framework, I would suspect that a lot of that is automated. So it's because and AI lends itself to help in that, in that variable creation from an automation standpoint. So I think it's it's very useful in that type of framework relative to other frameworks, which is where I've spent most of my time, which is on dealing with customers and consumers, where you have to do that manual work of organizing the data. In the IoT world, less so, because you're dealing with the sensor data. A lot more of that can be automated.
Yeah, I mean, you're going to have to do that work up front, but then once you've done that work up front, it's almost like a patchwork of cables, connecting this to this, connecting this to this, and then once you've done that, then it can be automated and can flow nicely. Mm-hmm. Yeah, like you're saying. And so that's a good point. And then that 85%, you can maybe cut that down and automate that in general.
Yeah, and that's where a lot of the, a lot of vendors, a lot of companies are now emerging or trying to see if they can solve that second stage, because we've got the math, we have AI, we have decision trees, we have all the tools, and as you said, many of these tools have been around for years, but now the vendors and the companies out there, who are talking to guys like us and saying, well, you're still not solving, the big issue is stage 2, which is 85%, which is like that variable creation, like creating that analytical file. So, I'm reading, I get all, I get the emails and literature, from the different groups that I belong. And, there's companies now that are saying we've automated the variable creation process. And I haven't seen, given what I know, I'm a little jaded that you can take, not in the IoT world. So the IoT world, I think that there's definite opportunity to do a lot of that automation in terms of the data, in terms of organizing the data. But in my world, I am a little jaded because of what I know and how we have to connect the data. And so I struggle with suppliers say, oh, we can automate all that for you. And I'm going, okay, well, show me. And I have yet to see a company that can really show me. There was one vendor I read about a couple of days ago that's basically said we could do variable creation. And I went through their paper, and basically all they're doing is they're writing R code. You're familiar with R as a software. It's R script. So the person still needs to know R and has to know the commands in R to automate. And I'm going, well, that's no different than SAS. No different than SAS. So it's you can call me, maybe I'm maybe I am jaded, but my jadedness goes back to what I know and to the long, hard work that data scientists need to do to string data together. I've done it, hundreds of times in my life. And believe me, as a data scientist, I'm very open. But if I have 8, 9, 10 files that I'm trying to group together into one analytical file, because that's not unusual, it could be 20 different files, you're going to automate that for me? Show me. And you're like, with all the nuances, the domain understanding that the data scientist needs to know, you're going to automate that for me? Okay. I'm all ears. I want to listen to what you say, but I've not seen a company create a push button. Okay, Rich, give us those 8 or 9 files, put them all in, push a button, and you're going to get a nice analytical file with meaningful inputs.
Yeah, and let's just open that up a little bit so everyone understands what you're talking about. So I think what you're talking about is traditionally, and then IoT is more homogeneous.
That's right. IoT is different. Right? Yeah, IoT.
So it's a little bit different. But traditionally, you're going to be getting all these different sources of data. And when you talk about creating, you're finding your variable creation or finding your, automating the variable creation process. What you're really talking about is, well, you don't necessarily have to do that. You could have all the variables from all the files, but I think what you're saying is that you're trying to collapse it down to meaningful variables so that you can stitch together the different sources of data. Right. And so what you've said is that is the domain of a data scientist, is being able to, kind of spitball in a way, but understand, we can collapse these variables down. We can bring this stuff together. There's a relationship between this. And then basically what you're trying to do is create a tight model, that has not a bajillion variables, specifically variables that are dependent on each other, because then that would make no sense. So I guess you're trying to create a model with independent variables. Is that accurate?
Yeah, what you're trying to do is you're trying to create a file, like I call it the analytical file. So you're trying to create an analytical file, which you then input to whatever algorithm you decide to use, whether it's a deep neural net, logistic regression, or vision.
This is your data source. I mean,
that's right.
The file that's nicely been packaged so that you can then deliver it on a platter to whatever that
to the algorithm. Yeah.
To the algorithm.
Yeah.
And then in the past, that algorithm could have been, just some simple analytical techniques, but they could be some discrete, let's call them discrete, analytical techniques versus another type of technique that's called AI. That's more a process that takes, again, all these discrete building blocks, let's say, and iterates upon them and networks them together. And what you're saying is this, automating that variable creation is pretty tricky, but then going to IoT, well, if we have homogeneous data and we know where it's coming from, at least from, one part of our data source, then maybe that is automatable. Maybe that is something that we could then stream in directly into these AI engines, so to speak.
Yeah, I think the IoT data and the sensor data does lend itself to more automation in terms of creating that input file which goes into the algorithm. So there's a lot more opportunity for automation in the IoT world versus my world of customer analytics, where there's that sweat and toil that the data scientist needs to employ to create that input file.
Okay. Well, I didn't expect this to go down in this particular direction, but I think it's been really useful, Richard. Can you tell our audience where they can find out more about you and your company and what it offers, just so we know.
Yeah, I would urge everyone to go onto our website, www.environicsanalytics.ca. That's our website. You can see the number of products and services that we offer. We offer three types of services. One is our data products. In Canada, we have close to 22,000 variables that relate to a particular geography.
Is this from Stats Canada again?
Well, what we've done, we've used Stats Canada as the source, and then we've created other variables.
Okay, so you pulled together these databases, is what you're saying? Yeah, that's what these data products are.
Yeah, so we've pulled together we've pulled together these sources, and then we go in, and then we will create other variables at a postal code or geographic area level, which work quite well and provide insight that pertains to that level of geography. We also have done work where in Canada we've clustered or created segments in Canada. Mm-hmm. So for instance, I might live in a cluster that's mature, middle-aged, professional. Right. Mm-hmm. That could be one. I'm just making that up, but that could be one cluster. And there are a bunch of houses or people that look like me that are part of that cluster. So
good for marketing.
Yeah, and so it's great for marketing. And so basically, we've carved Canada up into 68 different clusters. Data products represent one area. The second is software. So we have software now where our clients can go in and load their own data in and basically profile their data against the general demographics of, let's say, the Canadian population. So how are my customers indexing in terms of income relative to the Canadian population, data internally? And the third area I mentioned is the reason they bought my company, the Boire Filler Group, a year and a half ago, was to get more into the customized analytics, sort of the individual level customers, trying to build models and segmentation systems, but at an individual level. And so, we are providing that data science and data mining services for clients that perhaps can't do that themselves, or they want a different point of view. So, can you help us build a predictive model or a tool, or help us deploy some AI, within our company? So, we would provide, again, that customized analytics. So that customized analytics represents, the third area that of where the company generates revenue.
Now, how about IoT? Are you looking at creating an IoT practice?
Sort of at this point, it's going to be driven by customers, I would say. So as customers, like we're always, because we're a service company, I would say that we are open to look at everything. So, if there was a need if we were dealing with a company, let's say a health company that had IoT data, and they were trying, again, I'm going to give the example of a pharmaceutical company, and they were trying to look with issues of compliance, and they had a number of customers, and they had the wearables type data available. Then we would certainly, look at that relative to compliance. So I think where we would look at the IoT would be as it relates to customer analytics, and can it help us? Can we use that data to really, as you say, even build a better solution? So we've talked about AI trying to build better solutions, but can I use the IoT component to help? And
it seems to me, though, from this conversation, what has, I guess, the gears turning in my mind is the opportunity with IoT and AI, I think, seems like at least one of the opportunities is trying to automate that step 2 that you're talking about, and trying to streamline that so that, using your car example, and let's say it's a Tesla, that you're bringing in that data, whatever that frequency is, but you're bringing in that data and creating and having a live model, a live AI based model that you can just, that you don't need a guy like you, to pour over and put together. And so maybe you need you just in the first stage to, again, develop this patchwork. But it seems to me this automation and this automation of data, and then automation of statistics or analytics with AI seem like a really good fit. And that intersection seems to be interesting to me.
Yep.
Do you know what I mean?
Yeah, no, I would agree, Bruce, that in the IoT, this, again, because we've seen with some of the solutions that are coming from AI, it's not where AI is providing benefit is not just in terms of optimizing a given behavior. It's also about automating that we call it feature engineering or variable creation. So that's it's really two things, and that's in IoT that automation of feature engineering or variable creation is going to be much more prevalent, in my opinion, in the IoT world than in my world, at least for now. I mean, things are changing, but at least for now, I do see that the automation in terms of in terms of these tools working quicker is going to be a lot more prevalent in the IoT. Automation of features and variables, and then being able to come up with that optimal solution.
Well, with that, I'm going to say thank you and appreciate your time.
Okay. Thank you, Bruce. Thanks very much.
Okay, that was a good talk with Richard Boire. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book IoT Inc., published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support the show by buying my book, IoT Inc., or the ICIP training and certification program. It's how I pay the bills. Next week's episode is AI and IoT, a marriage made in data, with Anand Rowe. I hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Until next week, may your path to IoT business be a learning one.
You have been listening to the IoT Inc. Business Show.